Students, welcome back to Matrices and Systems of Linear Equations. So my learning outcome on this video is, at the end of the lesson, you must be able to write a system of linear equation in the form of ax equals to b. Solve the unique solution of ax equals to b using inverse and elimination method Gauss-Jordan. So in this video, we will be focusing on inverse matrix. Okay. Now, let's say we are given a system of linear equation with three variables. Okay, so three variables here are referring to x1, x2, x3. So you are given three equations and you are required to find x1, x2, x3. So what are we going to do? We're going to learn how to write this system of linear equation in matrix form. So A11, A12, A13 is written as your row 1 and multiply with x1, x2, x3. So you will be getting A11 x1 plus A12 x2 plus A13 x3 equals to B1. Okay, students. So once you have written this is a matrix that we know. Let's say A. Let's say this is matrix A. Now, next this is x1, x2, x3 is the unknown. X, okay, ax equals to b. So basically we would like to find x. Okay, now let's look at what happens when you written your matrix in the form of ax equals to b. Okay, so you have written this in the form of ax equals to b. Now we are required to find x. x1, x2, x3 is x. So how are we going to find x? We're going to introduce A inverse on both sides. Okay. So why we do this? We know A inverse multiply A will be giving us I, identity. And identity multiply any matrix, you will be getting back the same matrix. So at the end, how you want to find your x is you are going to take A inverse multiply with B. Now students, be very careful. Your placing of your A inverse must always be on your left hand side. Okay, it cannot be on the right hand side. Okay, so I will explain to you why this has to be on your left hand side. But first, we look at the given example. Okay, now let's say they have given us 3x1 plus x2 plus 2x3 equals to 11 and so on. Solve the following system of equation by using the inverse matrix. Okay, now, so remember, we're gonna try to convert this to a matrix equation. So how do you convert this to a matrix equation? So you can try this, student. Okay, so your first row would be 3, 1, 1. Okay, now let's do it on our next slide. Okay, so this will be easier. Okay, now your first row would be 3, 1, 2. Okay, let's check. Okay, yeah, correct. 3, 1, 2. Okay, now second row is 3, 2, 2. And your third row is 1, 0, 1. So we're gonna multiply with x1, x2, x3. Okay, so this is going to be equals to matrix B. So let's check on what is matrix B. So the answer here 11, 10 and 5 is matrix B. 11, 10, 5. So this is our first learning outcome. You are able to write your system of linear equation in matrix form. Okay, now next this is, let's say this is matrix A, x equals to B. Our aim is to find x. Okay, so we're gonna introduce A inverse on both sides. Remember, I've explained to you earlier, be very clear, your A inverse must be on your left hand side. Okay, so we know A inverse times A will be giving an identity matrix, and over here this will be A inverse B, and finally what is x? X is A inverse B. Okay students, now to be able to find x, we already have matrix B, but we do not have matrix A inverse. Okay, but we already learned how to find A inverse. Okay, so we have two methods. Either you can use adjoint or ERO. Okay, let's say I would like to find my A inverse using adjoint. So you can always choose any method that you are convenient with. So remember, finding inverse using adjoint, okay, the formula is 1 over determinant A adjoint A. Okay, so I hope you remember the formula. Okay, now we're going to find determinant of A. Okay, so how do you find determinant of A? I hope you remember. You can either use row expansion or diagonal expansion. Okay, now I would like to use my row because I got a row that has 0. Okay, so the sign for 101 for row 3 is plus 1. Okay, and the elements are row 3, eliminate row 3, column 1. We will be having 1, 2, 2, 2. Okay, and minus 0, I do not have to write minus 0. I'm going to go to plus 1. Okay, row 3, column 3. So the elements would be 3, 1, 3, 2. Okay, so this is how we find determinant if you remember. So this is going to be 2 minus 4 plus with 6 minus 3. Okay, so 2 minus 4 is negative 2 plus 6 minus 3 is 3. So the determinant of matrix A is 1. Okay, students. So we are done with the determinant. Next, we're going to find adjoint. Okay, so to find adjoint, we will find cofactor. Okay, we will start with cofactor of matrix A. So this is going to be a plus sign. Okay, eliminate row 1, column 1. We will have 2, 2, 0, 1. Okay, followed by a negative sign. Eliminate row 1, column 2. We will have 3, 2, 1, 1. Followed by a positive sign. Eliminate row 1, column 3. We will have 3, 2, 1, 0. Okay, so I hope you are following this. Now this is followed by a negative sign. 1, 2, 0, 1. Followed by a positive sign. 3, 2, 1, 1. Followed by a negative sign. 3, 1, 1, 0. So I'm going a bit fast here because we have done this in our earlier videos. Okay, so this is going to be 1, 2, 2, 2 minus 3, 3, 2, 2 plus 3, 1, 3, 2. Okay, so basically this is my cofactor of matrix A. So if we find the determinant of each element, okay, cofactor of matrix A would be 2, negative 1, negative 2, followed by negative 1, 1, 1, followed by negative 2, 0, 3. So this is cofactor of A. But the formula is not on cofactor. The formula is on adjoint. So remember student how to find adjoint. So adjoint A would be transpose of your cofactor. So we will be getting 2, negative 1, negative 2, followed by negative 1, 1, 0, followed by negative 2, 1, 3. Okay, so our aim is to find A inverse. So A inverse, the formula is 1 over determinant A, which is 1, multiply with adjoint A. So copy your adjoint here. Okay. So what is A inverse? A inverse is 2, negative 1, negative 2, negative 1, 1, 0, negative 2, 1, 3. Okay. So students, this is just the inverse. Okay. We haven't solved x. So we are supposed to find x, where we're going to take our A inverse. We're going to multiply with B. Okay. So we're going to copy our A inverse on our next slide. Okay. So what is A inverse, students? Okay. X equals to A inverse B. Remember, x is x1, x2, x3. So you copy your A inverse from your previous slide, which is 2, -1, -2, followed by -1, 1, 0, followed by -2, 1, 3. So we're gonna multiply with matrix B, which is 11, 10, 5. Okay. So now students, notice that our inverse is always on the left hand side. So I have talked about this in the beginning of the video. We must make sure your inverse is always on your left hand side. So why is this so? Remember, this is a 3 times 3 matrix and this is a 3 times 1 matrix. So this is the only way that you can multiply. These two matrices are compatible to be multiplied because the column and the row is the same. And your final answer is going to be a 3 times 1 matrix. Okay, that's your final answer. So let's say you can check out what happens if you write this as B A inverse. So remember student, the order of matrix B is 3 times 1 and the order of matrix A inverse is 3 times 3. So now can you see that this is not the same? The column and the row is not the same. Therefore, this is not compatible to be multiplied. So now I hope you understand why is it important to have your A inverse on your left hand side. Okay, now we're going to take row multiply column. Okay, so you're going to take row 1 multiply column 1. Okay, 22. Okay, 2 times 11 is 22 minus 10 minus 10. Okay, next is -11 plus 10 plus 0 and -22 plus 10 plus 15. Okay, so once you find the solution, you will be getting 2, -1 and 3. Okay, students, so remember we are looking for x1 which is 2, x2 which is -1 and x3 which is 3. Okay, so this is how we solve system of linear equation using matrix. Okay, so I hope you followed my video. Okay, if you can understand, please watch this video again. So I will have more example on my next video. So if you look at your handouts, we do have given you exercises. Make sure to complete your lecture notes and try the exercises. Okay, that's all for my video today. Thank you, students.